Right now, in 2026, there are humans who have traveled into the future. Not in a movie, not in a book, in real life. And the craziest part? The science says we could all do it. I'm talking about actual legitimate time travel backed by physics, proven by experiments, and happening right above your head on the International Space Station. This isn't science fiction anymore. Today, I'm breaking down the 7 scientifically valid reasons why time travel is not only possible, but some of it is already happening. And trust me, by the end of this video, you'll never think about time the same way again. But before we dive in, let me be clear about something. When physicists talk about time travel, they're not talking about some magic DeLorean. They're talking about bending the fabric of space-time itself. So buckle up, because we're about to blow your mind. Let's start with the most important fact. Einstein already proved time travel is real over a century ago. Reason number 1, time dilation from special relativity. In 1905, Einstein published his theory of special relativity, and buried in those equations was a bombshell. The faster you move, the slower time passes for you. This isn't a theory anymore. It's been proven thousands of times. Scientists put atomic clocks on airplanes in 1971, flew them around the world, and when they landed, those clocks were behind the ones on the ground by exactly the amount Einstein predicted. The difference was tiny, just nanoseconds, but it was measurable. Time literally moved slower for the clocks that were moving. That's time travel to the future, confirmed by science. Now, if you could travel at 90% the speed of light for a year, you'd age 1 year. But when you got back to Earth, over 2 years would have passed. You'd have traveled into Earth's future. At 99.9% light speed, the effect gets insane. 1 year for you equals over 22 years on Earth. Take a 5-year trip at that speed, and you return to find that over a century has passed. The problem? We don't have technology anywhere close to reaching those speeds. The fastest spacecraft we've ever built, the Parker Solar Probe, tops out at around 0.06% the speed of light. We need to go about 16,000 times faster. But here's the thing. We don't need to go that fast to see the effects. Which brings me to reason number 2. Astronauts are already time travelers, and they don't need to go anywhere near light speed. Every astronaut who's ever been to space has traveled into the future. Not by much, but by a measurable amount. The International Space Station orbits Earth at about 17,500 miles per hour. At that speed, time moves slightly slower up there than it does down here. Russian cosmonaut Gennady Padalka spent 879 days total in space over his career. By the time he retired in 2026, he had time traveled about 1/40th of a second into the future. That makes him the human who has traveled furthest into the future. It's not much, but it's real. He is literally younger than he would have been if he'd stayed on Earth. That's time travel. Reason number 3, gravitational time dilation. This is where things get even weirder. Einstein's general relativity showed that gravity itself slows down time. The stronger the gravity, the slower time moves. This means time moves slightly faster at the top of Mount Everest than at sea level. The difference is tiny, but GPS satellites have to account for this, or they'd be off by miles. Your phone's map app only works because engineers corrected for time travel effects. But what if we used extreme gravity? What if we got close to something with gravity so intense that time slows to a crawl? Something like a black hole. Reason number 4, black holes are time machines. This sounds like science fiction, but the math checks out. If you could get close to a black hole's event horizon without falling in, time would slow down dramatically for you compared to the rest of the universe. In the movie Interstellar, they got this right. 1 hour on Miller's planet near the black hole Gargantua equals 7 years back on Earth. That's not Hollywood fantasy. That's what Einstein's equations actually predict near a supermassive black hole. You could orbit close to a black hole for a few years, then return to Earth to find that thousands of years have passed. You'd be humanity's ambassador to the far future. The technology to do this is theoretically possible. The catch: the nearest black hole is about 1,500 light years away. With our current technology, it would take millions of years to get there. But if we ever develop faster propulsion, black holes could be our express lane to the future. Now, everything I've talked about so far is one-way time travel. You can only go forward. You can't come back. But what about traveling to the past? Is that even possible? That brings us to reason number 5. Wormholes might actually exist. A wormhole is like a tunnel through space-time connecting two distant points. Think of it like folding a piece of paper and punching a hole through both layers. Einstein's equations allow for wormholes. They're mathematically possible. In 2026, physicists are seriously studying whether they could exist in nature or be created artificially. If they're real, they could connect not just different places, but different times. Here's how it would work. You take one end of a wormhole and accelerate it to near light speed while the other end stays still. Time dilation means the moving end ages slower. Now you have a tunnel connecting two different times. Step through from the future end, and you emerge in the past. Congratulations, you're a time traveler. But there's a massive problem with this, which leads to reason number 6. Reason number 6, wormholes probably need exotic matter. To keep a wormhole open, you need something with negative mass. That's not antimatter. That's matter that has less than 0 mass. And we've never found anything like that. Some quantum effects produce negative energy on tiny scales, but scaling that up to hold open a human-sized wormhole would require more negative energy than exists in the visible universe. It might be physically impossible, but let's say we solve that problem. Let's say we build a working time machine that can take us to the past. We're still not done with problems. We're not even close. Reason number 7. Paradoxes might make backwards time travel impossible. This is the famous grandfather paradox. You go back in time and prevent your grandfather from meeting your grandmother. Now you're never born. But if you're never born, you can't go back to stop them from meeting. It's a logical contradiction. Some physicists think the universe would literally prevent you from changing the past. You'd be stopped by random accidents or your time machine would malfunction. The universe protects its own timeline. Others think backwards time travel would create a parallel universe. You change the past, but instead of erasing your timeline, you create a new branch. Now, there are two universes, one where you existed and one where you don't. This is called the many-worlds interpretation, and it's a legitimate interpretation of quantum mechanics. If it's true, you could travel to the past, but you could never return to your original timeline. You'd be stuck in the new one you created. But here's the mind-blowing part. Some physicists think paradoxes mean backwards time travel is simply impossible. Not because we lack the technology, but because the laws of physics won't allow it. Period. Stephen Hawking proposed the chronology protection conjecture. It says that the laws of physics prevent the creation of closed timeline curves, which is physicists speak for time machines that go backwards. The universe has a built-in defense against time paradoxes. So where does this leave us in 2026? Forward time travel is absolutely possible. It's been proven. We're doing it right now, just very slowly. If we can build faster spacecraft or get near a black hole, we could jump far into the future. Backwards time travel? That's where it gets murky. The math says it might be possible with wormholes. But we need exotic matter we don't know how to get, and we have to solve the paradox problem. Most physicists are skeptical. But here's what gets me excited. 50 years ago, black holes were just theoretical. Now we photograph them. 100 years ago, time dilation was a crazy prediction. Now it's proven science that makes your phone work. What seems impossible today might be routine science in 2126. Our descendants might look back at us the way we look at people who thought heavier than air flight was impossible. They were wrong about flight. Maybe we're wrong about time. The universe is stranger than we can imagine. Time isn't the rigid, unchanging thing we experience in our daily lives. It's flexible, stretchable, and maybe even traversable. And that is absolutely mind-blowing. If this video bent your brain in the best possible way, do me a favor. Smash that like button and subscribe to your Space Wizard. We make the universe feel accessible and mind-blowing every single week. Hit that notification bell so you don't miss the next one. Time is weird. The universe is stranger than fiction, and somewhere in the future or the past, another version of you might already be watching this video. Until next time, keep looking up, Space Wizards.